The first one is it's called Connect To, which is
it's really close to the ocean, so I guess that helps with wind and stuff. But I think if we could do something like that, that'd be huge. And then other, like, I think smaller things, but also they add up. They took a lot of effort and time into choosing what appliances they use, so they're really efficient and they just use less electricity. One cool thing is that I actually almost all the solar panels are on the side of the building, so we probably can't do something like that, but we can keep thinking outside of the box and see what our specific location could give us.
Yeah, it's interesting.
And then I have some stuff to the right. This is some stuff I just thought might be cool and interesting to consider. So there's some, I don't know if this is new, but I just heard about it. PVT solar panels. So this is one thing they might have used, I'm not sure, but it's solar panels, but also they get really hot, normal solar panels, so it can capture the heat waste and use that for water heating and temperature control. And then some kind of new stuff is like hemp insulation and hemp concrete. So hemp is just a plant, and it was actually recently allowed to be like commercially farmed. It used to be illegal because people thought it smelled like marijuana. But yeah, I think the coolest one is probably the hemp insulation because it's so much safer for humans, and it's like the process of growing the hemp in itself takes CO2 out of the environment, so that's a huge thing. And yeah, it's safer. It's a little more expensive, but it's really good insulator. And then the hemp concrete is also, that's pretty cool because even once it's in its cement or concrete form, it's still taking CO2 out of the environment, but it's not structurally super strong. So it'd be more for like, it can't take a huge load at all, but people are using it for certain construction. I'm not exactly sure why.
Hi, everybody. Oh, it's kind of lost.
And then, yeah, the last thing was just like an eddy turbine. They're like small windmills essentially, and they can capture some electricity and they look cool. So that was just something I thought. And that's about all I have. I have some graphs and stuff off to the side, or like tables, but that's about it for me.
Should we pause?
Yeah.
Oh, yeah. I'm sorry. I was here.
Single family challenge, and that was second. It got a second prize at the competition. So what I think was successful 2 years ago that wasn't successful last year was the quickness with which we chose the site and the focus on issues that we wanted to solve. So we chose a very typical Los Angeles lot, and we built on the issues that were being explored in UCLA architecture program of densifying low density residential areas, R1 lots. That was very effective because it had broad applicability across Los Angeles and allowed us to focus on like a typical lot as opposed to a very specific location. And I believe that the intention behind Solar Decathlon is to have this replicability in design and use conditions that are common. So that I just want to say that when choosing sites, choose the most typical site that addresses concerns that are pressing in our location. And I looked at some of the site selections. I thought that focusing on the outskirts of high density boulevards is a smart idea. Focusing on parking lots, redeveloping parking lots is a smart idea. Overall, there's a shift towards more public transport, more walkable communities in Los Angeles. And that is something that's driven by the 2028 Olympics as well as broader sustainability initiatives. Looking at Brooks Scarpa work is excellent because they are currently focusing on this kind of densifying. Their projects are bigger, kind of apartment complexes, but there's definitely there's information that is valuable on like even their Instagrams and throughout their projects. I would definitely look into that and what areas they're focusing on. They're very kind of activist architecture group. There was a competition last year called Low Rise LA. Do you have meeting notes I could be posting links to?
Yeah, I'm taking some now.
Yeah, I was also making notes. Yeah.
Okay, good. I've got links I could just throw in so to make it easy if you.
Oh yeah.
Is it
Do
on
you
the
want to share
drive?
screen or just put it-
Yeah, if you start,
Where can I find it?
it's what is this? That's one thing. You can just put it under. Yeah. And then just add it on.
All right. So you can also see this document. So the low rise competition is a competition that focuses on densifying R1 lots in varying ways. Some very interesting entries that would be applicable to attached housing are in the corners category of that. If someone wants to actually screen share,
Or do you want to log into the Zoom link or to, and then do you have to port to the HDM?
but you know what? I'm not going to be able to do that because I'll have to cycle between documents.
Oh, then it's okay then.
Yeah.
You want to share your screen? Or you want someone else to just?
Yeah,
all
it
the
would be great to connect it to that.
Did you post them somewhere, or I should just put a link with you?
Goes to the links and just click through to the links I post. Sorry, I was writing this as listening to Adriano and taking notes.
Yeah. Under project.
So there's some interesting entries in the category called corners that focused on developing two adjacent lots on the corner lot, on the street corner, into 10 units, which would fit the brief for attached housing very well. And if you scroll down a little bit, you can see the 3 entries, but even the honorable mentions, you can click through to their entries, which have some interesting packages. Just something for the architecture team to look at as a template for how this kind of development is addressed currently in LA. These were winners or honorable mentions through the competition sponsored by mayor's office in LA. So this is the kind of development that Los Angeles is actively pursuing.
These are all professional architects entrants.
It's a mix of professional and student projects, mostly are professional firms. Right. Next thing I wanted to say that staying in LA City would be smart because ZMAS is an excellent tool. And also, I wanted to say that when you look at zoning, during the previous meeting, I saw someone mentioned that, or in notes, that height of 1 would be a limit problem. Mostly zoning doesn't, even if the height category is 1 in LA, that doesn't mean that the limit is 1 story. It's just a specific specific kind of use case or height case. And here I'm posting a link to this PDF that has a summary of what the zoning codes mean in ZMAS. This is from a couple of years ago, but if you're interested in like if anyone's interested in GIS resources, I've got plenty of GIS players from doing research and for my MARC. So I can share those. Probably like
We have this in one of our folders.
you've got it.
Yeah.
Okay. As opposed, I heard you mentioning the stormwater capture not being maybe beneficial in our climate. It's actually in code that it's required by code for all developments, and usually the rain barrels are provided to fulfill that need, and they're not a great system. Also, infiltration is a so I have a link here to what's called low impact development. So those are the rules, and it has some links to softwares for calculating the sizes of rain capture systems. That's software is called HydroCalc. Also, when you pick a site, yeah, I mean, this is pretty code-based, but can also find a link to HydroCalc, which is just a little simple software. Another very simple software is the Climate Consultant. I posted another link for the Climate Consultant software, very simple software to get a climate model of your site. Originally developed at UCLA and now maintained by this team, this website, whatever that is. If you install it, you can create like a psychometric chart of your location and find out what passive design features could be used most effectively to limit use of energy. I heard someone mentioning facade-mounted solar panels. There is an interesting solar panel installation in the previous project that in which the facades open up and on that video, maybe if you go to like a middle, you'll see kind of about there. Or yeah, that was it. These facades are operable, and the solar panels, they're facade mounted, pivot out. Just the potential feature. In terms of life cycle assessment, there's a standard called Cradle to Cradle, and developed by William McDonough, I believe. So I'm linking just to that idea. There's a book associated with it. There's this project I like to link to because it's like aluminum facade system with aerogel film panels, very futuristic. But but if you, the cradle to cradle is also a certificate system, so it offers, there's links to places where to materials that are certified to have their life cycle considered in certain standard. I also, in terms of gray water permitting, I see that in LA it might be problematic. There's also code restrictions. Probably, this is just a PDF I found while Adrian was talking. So probably storage of gray water might be a problem, but if it discharges into irrigation area, should be very simple. This is something for concrete. There is something that I was very interested in. Another UCLA team that has a couple years ago was doing industrial demonstration for carbon.
This is my department.
Yeah?
Yeah.
So I'm not sure what's the story with this because the website for the team is not active anymore, but very interesting project, and it's at UCLA, so it would be interesting to have if there was any affinity. From what I understand, this process is only capable of producing precast concrete elements because they have to be cured in the flue gas chamber, which means that side casting concrete would be not possible. Something to consider in terms of lowering carbon footprint is using.
Yeah. So yeah, I'm actually in this lab, and what they're doing also, they actually kind of prove it in a not market scale, but demonstrative scale. So they actually went to a electrical power plant and used the flue gas to cure concrete, and actually they were able. So the electric help me with that. Electricity is produced with coal in this case. So the flue gas has lots of CO2, and they use it to cure some precast concrete units. In the case that it was proven was like building blocks. So, and yeah, they were capable of lowering the carbon footprint. So for that kind of information, I kind of have like direct access to it.
That's nice. So another thing, in terms of just really simple like inspo resources, there's this framework, Architecture 2030, introduced by Ed Mazzaria. The website has a lot of design ideas and just very simple design palette. Something that's could be useful for the architecture team just to like find resources for that would be consistent with the Solar Decathlon I don't know, ethos. Ed Mazzaria kind of introduced Solar Decathlon as a concept as well, so years ago. In terms of some like random things, I think it could be interesting to have like if you're using gray water, if you're using stormwater runoff for irrigation, using that for growing food could be interesting. That's something that's been done before, and urban farming is something that will, I think, increasingly be used.
Yeah.
And there's a very interesting precedent for vertical farming in a warehouse in Los Angeles. Different scale, but still the kind of sort of feeling science fiction.
I have a quick question. If we did, like, let's say we did use infiltration to capture rainwater, would that affect the gray water use if we were to use it for irrigation, like on the site? Or I mean, they're both being used for non-potable,
Yeah.
so it wouldn't matter.
Yeah, they can both be used. And actually, rainwater is cleaner.
Yeah, yeah, it is.
I mean, it all depends on how you design the system, etc. So rainwater is cleaner up to the point it touches the surface. So if you actually have a well-maintained system and well-designed, you'll have like cleaner water than rainwater.
Yeah.
But even so, you cannot use it for pumping.
Okay.
uses. If you don't do like an extra step in the treatment, so but yeah, it is actually cleaner and you can use both. Definitely.
Yeah, I would say that using that kind of recycled water for any non-potable uses would be no-go. Just it's too hard.
Yeah. Definitely.
And I also wanted to post in terms of like construction, the hype thing to do now is heavy timber, and this firm, Lever Architecture, I posted on the second page, has a lot of research for implementation and testing, just as a way to use heavy timber to make larger buildings that are more sustainable in a way. So this is the links I wanted to share. Hopefully some of those are useful. Any questions or?
Question. What would you say worked those 2 years ago versus last year in terms of like the design phases? Like what should we do first, or like what can we do simultaneously to make it more smooth, or faster and efficient?
I think what worked really well actually 2 years ago, we had economics students on our team that really helped us target like narrow down on the market that we were targeting. It really clarified some of the decisions in site and kind of materials we were using, because we looked at low-income communities, so we decided our systems needed to be very cheap. That really clarified our approach. And I think working with someone at Anderson School would be excellent. Just if they were interested in that kind of development. I know that often people in the business school, sometimes they're in the program called Fully Employed MB. So FM, yeah. So they're employed while they're doing their not sure, MBA, yes. There we go. So they're interested in doing projects with affordable housing often. So that's could be what Todd is thinking about connecting case to. There is a separate competition for affordable housing. That's yearly and sponsored by the US government in a similar way.
Yeah. Oh yeah, so that.
One thing that I was thinking before and that you said today, and I wanted to share kind of. I think they were looking for before at least like a site that would like be easier for transportation, easier to the energy aspects and everything. But actually thinking about engineering, if we like can prove that we solve the worst case, the easier case are like comprised, okay? So yeah, so I think you said something like that. So if you choose like a really challenging site that is actually okay feasible for us to do something, it's gonna be like the message is gonna be like more stronger, because again, if you can solve like the worst case, the best case is all right. So instead of looking for something that will make our life easier, probably we will not be as competitive. I don't know, compared to other, yeah, other schools or other design.
2 years ago, we looked at that as a motivation and looked for a site that was a little challenging, not too challenging, still very typical, but a site where there was a lot of pollution and noise pollution from the airport and neighboring highways. Didn't have tremendously good transportation either, but had bus lines, which are useful for in low-income communities. So we looked at that as being a motivation for building with passive house standards, which are highly insulated, which is not typically it's not a typical approach for this climate because natural ventilation is very beneficial, but having an airtight envelope also helped control not just noise pollution, but also particulate pollution in homes that are typically exposed to these sources. So in a polluted area, using this kind of envelope strategy helps solve.
What was the team structure like in the previous years?
So we had a team leader, the economics student, and we started off with her being a leader to lay groundwork. When in the middle of our project, pandemic happened, so we finished with a different leader in the architecture team. Was very production heavy, so she, Martha, I'm not sure if you contacted her, led the more submittal driven team, which I think was a good switch over to have the economics team lead in the conceptual, someone with like economics background leading the conceptual phase, and then architecture team taking over more at the end when production gets more extreme. We at the very end, we brought in a whole bunch of BHS members to help on
Kian?
Kian and
Sure. These are all new members, yeah.
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 We brought in a bunch of BHS members from different teams to help with specific categories, like mechanical, control systems, to enrich our concepts more. So some of the areas were developed very close to the end, just to meet certain standards. But we were developing architectural team. We developed very simple massing and concepts, working with just two people, me and the Martha, and we kind of this way we're able to bounce ideas off each other and showed it to a couple of our instructors. So that was really helpful just to informally get feedback on strategies we should use and should avoid.
That was nice. Thank you.
Yeah, nice.
Yeah, and also we're all now in big camp as well, so some of us are also helping out different projects. So like I guess we're now getting back to paper. Yeah.
I think I know there is a hydroponic aquaponic
Yeah,
system.
yeah.
People,
Me and Gavin are in there. Yeah.
that's interesting, as like that could really enrich the gray water reuse
Yeah.
portion.
I built an aquaponic system
at my house with my dad, so I've got some experience.
Wait, do you want to join the team as well?
What's up?
Aquaponics team?
I'm
So
I'm not a
Thursday-
starter right now,
But it's like Thursdays on 6 to 7 if you want, if you can make it.
yeah, I probably maybe, yeah.
Yeah.
I think that we had like, a little pond with a bunch of fish in there, and then with growing plants and whatnot on top of it, under these beds. And I think that like maybe integrating that with some sort of rainwater system on the roof or something like that could be really cool. So we definitely look at that.
Perfect. And Tomas, do you know the new team lead for Anna for Aquaponics is Anna?
Yeah, she contacted me.
Oh, great then. Yeah, awesome.
But I know the aquaponics team has some money to throw around.
They have a lot.
Yeah.
Yeah. 20K, yeah. And they're gonna build on like either bolster hall roof or a new tennis court place for the system. Yeah.
Hmm.
So they're doing big stuff, but they're planning, but it's gonna last for an entire year, so it's like a very long, very long commitment.
Are you planning on doing a build competition at all, or is it?
No, just for fun.
No, for solar decathlon.
Oh, sorry, Gabriel. The reason why we choose multifamily is also like learning from past year. Yeah, multi-attached housing. Yeah, it's because we learned from last year that from your notes you give us, so like yeah, not to be too ambitious. And at the same time, I talked to the person Rachel from Solar Decathlon is that there's a possibility that we can change to the build challenge in Midway since we're doing residential building.
Mhm.
Yeah, so that's why we're choosing this attached housing as a flexible choice.
I would say if you're considering that, when you talk to the people at Anderson School, like also ask them about potential fundraising for something like this. Building
Yeah,
building something in LA would be like $1 million. So the competition only provides like 50,000. So you have to like effectively find ways to fundraise that. Some like even TJF is like small money
I know, 5,000.
compared.
Yeah, I'll have Vanessa, our financial secretary, to handle that part.
So like the people in the MBA programs might be helpful.
Perfect.
I also wanted, on that note, my mom, like I said, she works in commercial development.
Design partner.
Yeah, so maybe even for fundraising, if we do need it at that point, I could ask her like what kind of developers in the area would be interested in being on a project like this.
Awesome.
Yeah.
Great, Andre. Thank you.
And yeah, she's still waiting to get back from like the person she talked to in LA. But what would you say would be like a good design partner? Someone in development, someone like knows more, I guess, like about market analysis and construction, also like architecture. Like what would you say would be the best?
The persons that would like the type partner that would get you the furthest would probably be a builder who participates in development.
Okay.
It's a slightly larger company that has potential to develop on their own.
Okay.
Is there any way before we wrap the meeting that we could walk through some of engineering fees stuff for like the MVPs?
Yeah, no, we should get back to doing the.
Yeah.
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 All right, great.
Great. Thank you.
So Oliver, I have you as the meeting host, so you'll be handling camera and.
Okay.
Okay.
I can go ahead and share my screen.
Oh, you can. Oh, that would be good.
And that's but you start recording because I have to head out for another meeting right now.
Go. Can
Yeah, for me, yeah. You know the record?
I? Oh, yeah. I think so. This one. Luge. Sorry. Anyway.
Yeah. I'll now get on record.
Should be able to see my.
Recording progress. Okay.
Yeah, and then just go to the Zoom, wherever you are on the Zoom.
Yeah, and it's probably let me just put your cover here so you can see the overall view,
Okay.
just in case anything. Yeah.
Okay.
So I'll try to go. Like, something that would want to by all means. Go for it.
Let's turn, would you mind, turn on the camera? So people-
Oh, yeah.
Other audio, so people can hear it clear.
Cool, okay. The kind of,
Oh, I'm muted.
you want me to unmute mine?
Yeah. so
Got it,
I
okay.
can hear you.
Is that cool now?
Yeah.
So just kind of overarching, so we're focusing on more the MEPs of the project. I would say kind of some of the overarching concepts for multifamily attached housing that we were talking about yesterday in our meeting was thinking about systems that need to be kind of individualized for each of the families that might be inhabiting in this, like kind of their needs. But you know, thinking about these systems is something that as a whole that's breaking off to you know have those kind of individualized sort of just like you know working to each family. So looking first at the HVAC. Talking about some of the mechanical systems. We were talking about different ways to actually heat and cool the space. Something that I had talked about with Tomas last year for the project, just thinking about schools. I mean, how, you know, you have different spaces that are gonna have to have different, you know, sort of climates in them. There's a pretty cool sort of system that's out there that's using heat pumps. So, you know, kind of moving on that wavelength of electrifying as much of the systems as we can. So we're not using natural gas or anything else that's gonna have some, you know, some negative impacts on the climate, on the environment. Deckless mini split heat pumps. So you're not using any sort of duct work, and it's essentially, imagine like, you know, one single AC unit that's like on a wall that they all sort of respond to the same central system, but can be broken up and controlled individually. So that could be, you know, something that would be pretty useful for multifamily housing. In terms of a case study, there's this building called the Pixel Building in Australia that's got a ton of really cool ideas. I actually did a case study on it for one of my classes in the summer. Just to show you guys what's going on with this. So this is the building right here. It looks pretty, you know, futuristic on the outside. I would say that kind of the history of it is that it was an effort to kind of use as many greener, sustainable concepts as possible to make a net zero building or carbon neutral building actually. A couple of the cool aspects. So they've got obviously a green roof on top with solar panels, and then some of these wind turbines. Let's see, for the gray, they have a pretty cool gray water system, gray water reuse system. I can totally put this in like the Google Doc for anyone that wants to look at some of the stuff that I said, but I would definitely check out this building. They've got a really cool heating and cooling system where they use if they want to heat the space, they actually heat from the top down. They kind of utilize natural convection. To the right here is talking about the cooling system where they actually cool they cool from the top down and then the heat from the bottom up. So they kind of work like, I would say that they have kind of systems that work differently to sort of cater to that natural convection. They actually use the exhaust from either the heating or the cooling. Like, let's say that you want to cool a space, they'll take the hot air and use that as part of the heat exchanger to actually, you know, get some of that cold air from outside. We were talking about some of the waste from either the toilet or sinks. There's an anaerobic digester, which is basically just breaking down organic compounds without the presence of oxygen. They use that to actually produce methane and then sell it back to the city for whatever use that they kind of want to. I think that would be cool to definitely talk about some sort of system that breaks down maybe the food or other waste on site to either use to our advantage or, you know, give back to the city. Let's see what else is there.
mean, I guess that's it for the Pixel building. There's a couple other cool stuff. They use natural lighting to with those sort of angled panels to just you know, reduce the need to actually have lights on during the day. They have some pretty innovative water management stuff. Let's see, in terms of the plumbing, kind of like what Adriana was saying, you know, low flow water features, want to think about some good rainwater and gray water management systems. So I think that we were, the Pixel building has a couple of those, and we were kind of talking about a couple different things that we could use to, you know, those are kind of still in the talks about what we could actually do specifically. Looking at electrical systems, obviously, you know, looking at LED lights, because those are just, you know, the most efficient stuff that's out there. Newton was talking about, you know, we really want to make these like smart homes so that we're utilizing sensors, we're utilizing different sort of languages or real-time data to actually try and optimize the efficiency of the building. Smart glass to reduce the amount of heat that's coming in from the sun. You know, smart light bulbs, using motion sensors.
When you say smart glass, you mean like glass that's actually like translucency controlled? Or
Yeah,
like
so-
glass?
Yeah, so Oliver was actually talking about this yesterday. It's like if there's a sort of, I think it's like if the sun's hitting the window at a certain angle, it'll actually go opaque to reduce the amount of light that's coming in and will effectively, you know, reduce the increase in temperature caused by the sun. There's also, you know, sort of shading systems that if the sun's at like a certain angle, there are sensors that can actually detect, you know, that sort of solar incidence, and it'll, you know, lower shades if you want that to happen, and just kind of all sort of around the idea that we want to use, if we're going to be working in LA, we might as well use the unique kind of natural climate that we have here. That's not too hot, not too cold. You know, it's sunny. It's always nice here.
Excuse me. Yeah, I would add is in my materials class, I presented a really like new approach, sort of to use like organic materials, which is like cellulose that they can use for many things in the nanoscale. And in the market level, we actually have the window glasses made of cellulose fiber.
No way.
And
That's so cool.
Yeah, yeah, it is transparent. It is high transmitted. It has high transmittance to light and low transmittance to heat. So yeah,
That's really
it's
cool.
pretty
Okay.
interesting. So it's
Sweet.
it's sustainable, and it has like enhanced properties that we can use here, and they are in the
And
nanoscale.
I think I've read about that too.
Yeah. So yeah.
And so are they kind of like tinted windows? They have different. You can have like different colors, right? Or is it clear for the
I'm not
most
sure. I
part?
just looked at the access, and you don't need like to do anything, to do any controlling. It will just like let the light through and not as much heat. Yeah.
Right. Okay. Awesome. Yeah. So another thing that we wanted to just kind of emphasize is like electrification of all of the systems. You know, there's electric water heaters. There's heat pumps now that, you know, sort of take away the function of both the furnace and an AC unit. So talking about how we want to try and, you know, electrify these systems and make them as smart as possible is kind of, I'd say, the big takeaway from some of the MVP stuff. But if you guys got anything else, yeah, go for it.
I could just mention some of the solar systems that we were looking into, which was a possibility of a AC and DC like home grid, which is a separated grid from the city's grid, but it's one that has both AC and DC components. So you're gonna have two separate solar arrays. One is going to, for example, a 48-volt battery, which will be DC, and that can power appliances in your home that only require DC power, and it reduces the energy waste by a lot because a lot of times in solar homes, you're converting the DC energy from the panels into AC through an inverter,
And then back to DC.
To go to the appliances, so you're just like losing energy in the process.
Is there like a market for existing like DC appliances? 'Cause, like all modern appliances can be AC, right?
Not a lot of appliances. I think some like some smaller appliances are tend to be DC, and that's why like computers have like a block.
Yeah, well, they have a transformer on the transformer to DC, right?
Yeah.
Yeah, we're definitely gonna like investigate just, you know, the kind of typical appliances. If there's anything that requires DC, that's like just something in talks for sure.
I don't know off the top now, but I'm a place to appliances or AC. But it can definitely help with reducing energy loss during that time. And it also kind of gives you some, when you have multiple appliances on a single electricity line that has AC, they kind of feed back power and they reduce efficiency further due to apparently something called resonance, which can be solved through this as well.
Yeah, and actually, I think you were talking about like control systems. I mean, for seniors, you'd probably take in 107 and 171 for you know, mechanical engineering. So we can definitely model some of that stuff if we want to, you know, to go more in depth and provide some of that.
Electrical engineer have an opinion?
Well, I mean, yeah, like, there's like some stuff at the top right that I have. Yeah, essentially just connecting everything like everything to like pretty much this simple pretty much this simple computer. You pretty much like control everything like because I mean you're in LA, so the internet is like I don't think it's that much of an issue. So there's a lot of like there's many different ways you can like utilize like the internet and like just like automatic systems itself because like even like the Nest Smart thermostat, like even something like that that's really like developed now, like even use like your phone location sensor and stuff and like use your preferences whenever you walk into a room and stuff, and then you can model all that stuff and like automatically like put these settings for you without you having to like manually set them yourselves. So there's just like overall there's just like a lot of there's just many different ways. Like you can even like detect like if the temperature is like going like decreasing at a slower rate, and there might be something wrong with like, your HVAC system or something. So yeah, there's pretty much there's just like many different like just like automatic systems itself. And like there's a study done by like schools like in Nigeria and Germany. They were testing even though they were for family homes, but pretty generic. But they use like Design Builder and the Energy Plus like, software, and then they were able to like model that. Like so, the baseline you can see from the far left is like if you have like zero like automatic like no like automatic systems, it's just like you manually changing everything, like the amount of like power you can waste, and so the more like sensors and things that you use, and the more data that you obtain, the smarter like these systems can just automatically run by themselves. And like so I know like all of the design of like architecture and the building itself can help, but these extra like feedback systems and things can that's like strong cell just optimize the work to like the best extent even in like times when maybe like the weather isn't like optimal.
Yeah, kind of adding on to that, one of my friend's dads works for this company called Carrier, and they released this thing kind of in this past year that I guess unifies the languages that all of these different technical systems speak. Because you imagine if you want to optimize your HVAC or versus your lighting, you know those like have very different languages for actually optimizing them. But what they do is they basically take, I guess, the equivalent of their IP address and sort of unify the language that they're actually like speaking, so that you can have real-time data that improves that sort of optimization process. I'd say in the past, it's historically taken a lot longer to accumulate that data to ultimately, have your system respond in a certain way. But they're doing some really cool stuff to actually, like really improve that energy management. So that's it there. I don't know like too much about it. He gave me sort of a high level overview, and it seemed like a lot of it was maybe sort of top secret information, so he couldn't tell me. But just something cool to consider. Just to wrap it up a little bit, down here in the left, just had a couple case studies and to talk about like retrofits for multifamily housing. I'm talking about just affordable housing. If you wanna check those out, and then Jared's stuff's over here. If you had anything else that you wanted to add, Jared.
Pretty much went through kind of like these slides, basically kind of, big picture, kind of with electrifying appliances and looking at, some of the like implementation of using heat pumps as opposed to, traditional AC and furnace. So those are just pictures that have like examples of that. And also details on like, when we're incorporating, renewable energy, like using batteries on site, to be able to supply that energy at various points of the day. So, yeah.
A couple things I just thought of when we were talking a lot about the smart systems, maybe for us, since like they're probably really customizable, maybe the communication between the individual units working together. I remember someone maybe from the presenter from last week saying houses on the same block would like communicate with electric chargers or charging at separate times and communicating with the need of the grid around it. So like maybe, I don't know, just one thing I thought of was like washer units. I don't know how that would work, but it would kind of seem wasteful for every unit to have its own washer dryer, stuff like that. But also just like communicating between the units. I don't know if we can think of systems that could lower the usage of different things.
Yeah.
I'm not sure.
Well, like there's like everything that was done like in UK. It's like their project, and we'll pretty much like they have these sensors and all these all these like automatic things that they can pretty much track when like you use like electricity like that. Chart thing shows like when like electricity is used the most. So like the fact that you get like there is the technology to track all the data, you could just probably like even like make an app or they can make an app or some software and that could just straight track and that could like share with everyone. So I think like as of now like the internet is something that is really prominent, so I might as well like take advantage of that.
Yeah. And I agree with what you were saying there. That architect that I had said, Bjarke Ingels, but I think he does a really good job of for some of his multifamily projects is still, even though it is all these individual, units, he does a really good job with like unifying the building, or I guess like each of the components of the building as like a whole, with like he has like terrace gardens that are like in sort of this like step pattern where like all each of the units kind of work really well together. So like I think that definitely like working with the like the other like sub teams here to like I guess unify each unit while at the same time like treating their systems individually is going to be like a huge like factor in this. So that's like I'd say like all that we had. I know it's like 1:17, so probably should.
I had a quick question for Adriano. We talked a little bit about the end of life, like what happens at that point. So this is, I mean, the building has a long life cycle, I guess, but what are some of the key things to focus on when you're trying to design a house that at the end of its life cycle, you can, I guess, use as much of it for recycling or downcycling?
Yeah, nice question. I mean, okay. First of all, if we can enhance, increase the service life, it's gonna be awesome. Okay, because you're using the same resources for a product that will last longer. This is one thing. The other thing is, one other aspect that we could consider, like to choose one material compared to the other, is knowing if the recycle pathway is like consolidated. For example, when we talk about glass and aluminum, they are pretty much consolidated. They can be recycled really easy. I mean, not easy, but it's simple and it's consolidated. So this is one other thing. And yeah, I mean, for concrete, we can reuse concrete to produce more concrete. So probably downcycling, probably we will, I mean, concrete from a high scaper to a pavement, but we are still using it.
So like, would it be key to try to make so that it's easy to sort all the different resources at the end when you're demolishing?
Yeah.
Worth it instead of just crushing everything.
Definitely. So when you say like, do you guys know this sort of expression, design for manufacturability, design for safety, design for assembly, design for. So in the eco design, we also think about that. So we want, in the end of the day, like to have the fewer composite materials. So the most part, the pure they are, the probably the better, the easier they are to recycle. So yeah, and it will really depends on. So I have another presentation on eco design. We can talk about this later. And yeah, so for metals, it could be easier. I mean, if they are not in a composite phase. So yeah, it really depends on, but it is actually something
So
to
like,
think
for
about.
example, it would be a good design practice to have a bunch of the piping and stuff in like the same section of the building so that taking apart, you don't have to go through the whole building, taking pipes out.
Yeah, I think so, definitely. And as we are talking about like attached houses, so we can talk like about attached systems, other things that can be modulated are so it is pretty easier to like get the materials from inside a drywall compared to a very rigid wall made out of concrete and everything. So yeah, they are easier to separate, which is good, definitely. Yeah, one thing that I would suggest, I actually have to go as well, is I was thinking about the AC option. AC, no, what is it? Continuous current, DC, right? Electric cars are a really big deal now, and could we have? I don't know. I'm asking you guys, the electro engineers. Could we have some sort of power station in the house? Would a DC current be like feasible to charge the car batteries?
Yeah, so, like Tesla battery pack is what was used like up to the way the last couple of years, which is essentially just like a huge battery. I think it's lithium ion or lithium polymer. And those will make DC power hard, so that would be like an efficient use of DC power coming in instead of converting it to charging that.
I mean, it would be like really expensive, but yeah.
And I was thinking about like the life cycle assessment of energy itself, right? Because not all energy is equal. If you think about energy coming from a coal power plant, they're like emitting a ton of CO2 for each like kilowatt hour or whatever, versus what you're producing from the solar panels. So it might even be better in terms of the carbon footprint to store it using an expensive battery rather than using from the grid and then giving back to the grid.
Yeah, the only thing there is you invest a little bit of carbon, like to build the system, to maintain the system in the end of life of the system. So if you can offset that during its operation, then the shorter the better. Nice, you know what I mean? So photovoltaic panels, they in a few years you have the economic payback and also environmental payback. So I don't have the number on the top of my head, but it is actually not more than 10 years or so. It should be like 5 or less than that. So yeah, but when we speak about batteries, more batteries, more environmental footprint, because batteries take lots of metals, lots of difficult things to deal with, not only to to produce it, but in the end of life. So one major thing in the end of life of electric cars is there is recycling in the end of life. So we actually go through that. But probably, I mean, at some point it will pay. What I mean, so yeah.
That's like, I was mentioning the funny meetings, like one thing was like, how to assess for items that don't necessarily, for buildings completed already. But for like specific appliances, there's not always like, so that would be something that for us, you could like guidance on that in the.
No, yeah, definitely. And if we have even a rough idea of what is going on there, we can do a rough estimate and say, this should be this or a little bit more. Yeah, we can always do like with a reasonable degree of uncertainty. Yeah.
Quick comment on the DC charging. The general like home chargers for electric vehicles are AC. So your house has an AC power, but there is DC fast charging for electric vehicles. Tesla, like other companies have that. So it could be interesting to have fast chargers on site maybe, and then you could go directly from solar panels to DC to the car.
Yeah. And if it is feasible for one house, we can think of like 50 houses, and it's gonna be like a 50 price, a 50 or something. I don't know. Just saying that for a single house, it could be difficult, right?
Like if you look at a charging station, like a charging station, like map, I guess in LA, there's like
Check, right? Check, right?
It might not even be like a charging station like a lot of houses. It's already available.
Cool. Okay, we should get back to the studies. We're almost done.
Yeah. Sorry, guys. Thank you.
Okay, see you.
Yeah. Come back in. Sorry, it's going over. Yeah. Okay. Does anybody else have anything? Architecture? Who put this stuff up over here? Someone who's not here? Okay. I'll just really quickly go over some stuff I did. Take a look at the mural board later, but essentially I did look at the city made to allow these two parking lots. To look into doing selling the parking lots development. They don't have like a formal request for information, but it does include also the 426 parking lot, which is that smaller parking along the side, or the larger one. I know we were a little worried about the size of the larger lot not working for housing, so I think we could just use that smaller lot and it would be okay. So that might be the best way to move going forward. There are it's actually like a pretty popular area, Lemert Park. It's got a new transit station coming to it this year. It does have a bunch of other development coming up nearby. Some of them are modular. As you can see here, just the prefab units. In this one, which is 4252 Crenshaw. So there are two main architects. One is like architecture group. The other one is like KTGY. So potentially follow up with them and ask for advice about the area. And then below here, I've just posted some kind of general links. Got this prefab book. So we can read that and trying to post some stuff. And then the rest of these are just kind of are the architecture industry case studies on modular construction. So
those projects are projects not on the site necessarily, but nearby.
Yeah, these are actually pretty close by. So Crenshaw is in that same area. So it's totally been no wait.
I was going to ask who filed the motion for the conversion. The city.
And I think they're basically trying to get proposals for that parking lot, right?
Yeah, so I tried to look through this place down here, Economic and Workforce Development Department, for the RFP, but I couldn't find it. I don't know if it's delayed due to COVID. But I still think it's a viable story to tell for going forward with our development. So I think that checks out. Cool. yeah, take a look at that. I would say in terms of next steps, what we could really use is like some concrete takeaways from each of these case studies. So if like each of the engineering teams could go through, like identify very key aspects of what worked in buildings and things you research and how it would be applicable to our smaller attached housing project, that would be ideal.
So are we on 2 slides?
No. The model is just based on, since we just like we used to choose like the very big site, so checking basically always would be not really appropriate to leave so much space. So,
Okay, so it's
yeah, but that would change. If we would back on the console.
I think it would be helpful also if we could have some more insight as to what architecture's goal is, like how many stories, how many.
Yeah.
that would also help a lot.
I think we'll have a deeper look at that.
And then like, any of you guys have like super specific visions or like cool lines you want to implement, then we can also think about how.
Yeah, but one thing I would like to make a remark is that like of course like you guys just presented quite a lot of like cool systems and ideas, but just keep in mind that it may like cost quite a lot like to implement all these new systems. So I guess we just have to make a balance between adopting like everything digital. Maybe we can work something in the architectural aspect, like to make some passive designs in order to compensate with something that we cannot use.
yeah, it's like ultimately it's like an optimization on like ultimately we want there to be the least possible need for mechanical and electrical systems.
Because I feel like if we're doing like 12 units maximum, then like the digitalization or like the smart control, I'm not sure if that's like really applicable on that scale. Yeah, so just keep in mind.
Something that we could do is like these systems, you're always able to retrofit it later.
Yeah.
So like we could have like future, the building in 20 years or whatever, when we could retrofit these better systems to make it more sustainable.
Yeah.
The last for the previous years, did you guys, what kind of like electrical systems do you guys have? Was it anything super advanced or was it pretty, sounded like it?
We designed a very small size. We had solar arrays on the canopy, so with potential for expansion. Minimal setup, potential for expansion. Potential for battery, but no battery pre-installed at the outset, which would imply more of the current code. And we did mini split AC system and another boiler and the outside of the thermal as well. For control systems, we had control systems, like smart control systems for lighting. But you've got a lot of potential in housing because you've got up to 12 units that could be sharing some of these more expensive resources infrastructure.
Is everyone have a good idea what they're gonna do this week?
I think that's.
Yeah, did the PM want to stick around after just to go over stuff?
Yeah, I have to, right, you could just like text me or I can call when you guys know that just, yeah.
Thanks, guys.